Welcome back to our automotive testing series. Today, we are going behind the scenes of automotive validation to demystifying the bug lifecycle. Okay, we aren't just looking at software glitches anymore. We are tracing the journey from a hardware in loop failure to a verified safety critical defect fix. It starts with a failure in the digital reality. Imagine an automated hardware in the loop HIL test for an advanced driver assistance system, which is ADAS. During a high-speed simulation, the lane keep assist suddenly disengages. Imagine like this. The trigger, what is the trigger here? Telemetry detects a camera sensor packet loss exceeding 20%, flagging a catastrophic system failure. In a vehicle's neural network, a single glitch can trigger hundreds of cascading error codes. The first engineering task is filtering that noise. We use log analysis and duplication to consolidate raw telemetry into something we can actually work with, actionable defect tickets. A defect is only as good as its data. A perfect ticket includes the software version, hardware ID, and the diagnostic trouble codes, DTCs. Most importantly, it must have CAN trace attachments or ECU measurements and its extract, reproducible steps on the hill rig. Without this environmental context, an automotive bug simply cannot be isolated. Not all bugs are created equal. We use a triage matrix to balance severity against priority. A brake-by-wire latency issue is an immediate stop ship because it impacts safety. Meanwhile, an engine stall that only occurs at minus 40 degrees Celsius while adjusting power seats is an edge case slated for a later release. Once triaged, we move to root cause analysis, RCA. Engineers use fishbone diagrams to systematically isolate the fault. Is it a hardware radar alignment drift, a dropped CAN bus message, or perhaps a timeout in the software control loop logic? Like this, fishbone diagrams are driven. To find the answer, we go back to the logs. By sniffing the CAN bus, we can pinpoint the exact moment of failure within the vehicle's communication network, tracing the signal path from the camera ECU to the central ADAS domain controller. The resolution process is a strict state machine. A ticket cannot progress on premises. Every transition from new to assigned to in-dev requires hard data, including code reviews and documented unit test processes like that. Proving the fix works is only half the battle. The logic gate is the hill regression test. Revalidating the entire system ensures the new code hasn't introduced regression failures elsewhere in the vehicle. If it fails here, it goes straight back to the development. It loops back. A resolved defect is more than a closed ticket. It is transformed into a permanent automated test script. This upgrades the vehicle DNA, ensuring this specific failure can never reach production again. In the end, defect management is platform architecture. Through systematic triage and rigorous validation, we don't just fix bugs, we forge a safer, more resilient automotive platform. So here the system state will be like verified and secured, and it will be signed off. Thank you.